Today we're going to be going over data types and variables. So as you can see, I'm using Visual Studio Code. I wrote it here. Visual Studio Code is just another Java editor. I know in the last lesson Sophie was using Eclipse. It's pretty much the same thing, and it should be very easy to follow along regardless of the Java editor that you're using. I'll also be using Terminal to compile and run the Java code. I will walk you through how to use that as well. Okay, so we're going to start with the most basic data type, which is an integer. I'll write it here. In Java, it's called an int. So data types in Java are used to declare variables and basically tell Java what the variable is going to be. So when Java sees int, it knows that the variable is going to be a whole number, no decimals, and the variable will be an int for the rest of the program. So we're going to start by declaring our first variable. So we can say int n equals 3. What we're saying here is that n is an integer, and we're setting n equal to 3. What this is actually doing is assigning a memory location to n. The memory location is named n, and in that memory location stores the value 3. Now, just to show you what Java sees, we can print n, go over to terminal, and type in javac, and then the name of the file. So mine is hello.java. And you have to make sure that you are in the same directory as your Java file. So my file is in desktop, so I'm in desktop on my terminal. So once you do that, that is compiling your file. So every time you make an edit to your file, you need to do javac and then the file name. But once you've done that, to run the file, you do Java and the name of the file without the .java at the end. And this is only for if you're using terminal. If you're using the runner in your Java editor, then you don't need to do this. Okay, so it printed 3 because that's what n is. So variables are useful for not using the actual value. You can just print the variable and get the value anyways, and then if you want to change the value of n, you don't have to go and change every single one, you just have to change it at the very beginning. And this will be very useful and necessary for later programs. Okay, so that is an integer, and I'll show you if you try to set n to a non-integer, for example 3.0, this would not be considered an integer, and you get an error, incompatible types. So you cannot set an integer to a non-integer when initializing it. However, if you use what we call casting, when you just say, I want it to be an integer by using parentheses int, then it will set the variable to an integer 3. So another way to initialize a variable is just by not giving it a value and just telling Java that you're going to have this variable and you'll tell Java what it is later. And so that's very useful in making the code easier to understand if you just put all the variables initialized at the beginning and then later in the program you can set them to a value. So if I put int n, just initializing it, and then say n equals 4 to give it a value, and then n is 4. So if I've already said int n, then I don't need to put int anymore because Java knows what n is. Java recognizes n. And now we can try using scanner. So as you can see, I've already imported scanner like from the last video. We can say system.out.print enter an integer. So this is what will be printed. And then, well, first we should make a scanner object. So scanner in equals new scanner. All right, and then we can say int n equals in dot next int. So remember in the last lesson we used next line because we were taking in a string from scanner. Now we're taking in an int, so just use next int. So enter an integer, I'll enter 6, and it prints 6 because 6 is the value now stored in the memory location that is under the name n. Alright, and of course if you enter something that is not an integer, you will get an error like before. It must be an integer, otherwise scanner will not know how to read it. And something else we can look at is integer division, which I think will be gone into in more depth later, but if we, for example, set n equal to 3 over 4, which is 0.75, which is not an integer, then we see that n is 0. And this is because Java, when reading this line of code, Java will first evaluate everything that's on the right of the equal sign. It will evaluate that first and then set n equal to whatever that value is. So it sees 3 over 4, where 3 and 4 are both integers. Integer division in Java is basically saying how many times can 4 fit into 3. So 4 can fit into 3 0 times, so it's going to be 0. Even though 0.75 technically rounds to 1, it's not rounding. Similarly, if you do n equals int and then say 3.6, then n will also become 3 because it's essentially doing front-end rounding. Alright, so I think this is a good start on integers. We can move on to the next data type, which is doubles. Alright, so I'm going to comment out this line of code so we don't have to keep printing n. And we will move on to doubles. Alright, so a double is essentially a decimal. It can store 64 bits, which is approximately 15 or 16 significant figures. And the other decimal type is a float, which I can put here as well. I personally always just use doubles because floats can only store 7 or 8, and if you're not doing a very expensive program, then you might as well just use doubles because they can store more. Unlike with the ints, if you set a double to an integer, let's say double d, if you set a double to an integer, it will just set that double to that integer, but it will make it a decimal, so it will put 0.0 at the end. But it will not give you an error. So it becomes 3.0. And then we can look at double division. So if we do 3.3 over 4 here, you might expect that it will be 0.75 because that is a double. However, it's actually 0.0 because remember that when Java reads this line of code, it first evaluates this side. It first evaluates this side and gets 0, and then it sees that it wants double, so it makes it 0.0. So if I split this into a couple steps, the second step is basically double d equals 0, and then it becomes 0.0. So to prevent that, if I want d to be 0.75, I can say d equals 3.0 divided by 4, where 3 is no longer an integer, it's a double, and I get 0.75. And then similarly to what we did before with scanner, you can just say, you can use next double to read in a double for scanner. Now we are going to move on to strings, which you've probably heard us say a couple times. Strings are anything in quotations, so typically this is words or like phrases. And the way you declare a string, I'm going to comment out this print. Alright, the way you declare a string is using the word string but with a capital S. So let's say hello. Alright, and you can use double quotes or single quotes, it doesn't matter. The reason we use a capital S for string is because a string is an object, which we'll learn more about later, while ints and doubles, and later you'll see Booleans, are primitive types. So always remember to use a capital S for string. If we call this one S1, and then we can make another one string S2 equals world, and I'll show you another way to recreate the hello world program that you made in the last lesson. So let's say system.out.print S1 plus, we can put a space in between, then plus S2, and plus maybe an exclamation point. And there you have hello world again, but using variables this time. And notice that actually the entire thing in the print statement is a string. Java knows that when something is in a print statement, it automatically turns it into a string so that it can print it for display in the terminal or in whatever runner you are using. Okay, now we can get a better understanding of how memory locations work. So let's say we don't set S2 to world, we just declare it, and instead we set S2 to S1. Right, so we can set S2 equal to S1, and then you'll see that it recognizes S2 now as S1. Imagine this as when you set S1 equal to hello, you're sort of pointing an arrow from S1 to a box that says hello. And then when you set S2 equal to S1, you are pointing S2's arrow to the same box. That would be a way to visualize it. So now they're pointing both at hello. And now let's look at, let's get rid of S2 and just focus on S1. Let's look at string concatenation with integers. So if I put S1 plus 1, then it will print hello 1. So it just puts 1 at the very end of S1 and makes a new string that says hello 1. Now what if I do hello 1 plus 1? It will do hello 1, 1. So it will not recognize that these are both ints. It will not add them because it goes from left to right. So it just puts the 1 at the end and then puts another 1 at the end. If we want it to say hello 2, we can put parentheses around the 1 plus 1 so that Java will evaluate 1 plus 1 first and then add that to hello. So here we see hello 2. Strings are very widely used all the time. It's very good to have a good understanding of what they're doing. And now we can move on to Booleans, which are the last type. So a Boolean is any true-false value. It either stores true or false, and Java recognizes the words true and false. They'll change color if you're using a Java editor. So if I say Boolean b equals true, then we have b set to the value true. I could also say b is false, and it recognizes false as well. Let's set b equal to the expression 1 is less than 6, which should of course be true, and we'll print b, and we see true. And of course, if we change this to greater than, we will see false. Booleans are extremely useful in loops, which we will learn about later, and you also use them with certain equality operators, which we will also see later. So later you'll understand why Booleans are incredibly necessary in coding. I will leave you with a summary of what we did today. This covers the basics of data types and variables. You will have an assignment that sort of mixes all of these together and tests if you really understand what each data type is doing. But I encourage you to go explore on your own. Obviously, we didn't cover everything here, but the best way to learn and understand coding is by trying things. So I encourage you to test out some things, see what'll work and what won't, and enjoy the assignment.